Oh, okay. Sorry about that. Um, so today I'm just going to do a little review of the doubling life and the half-life equations and work through a couple practice problems that will be helpful for the quiz and just in general. So there are two different kinds of equations. The two models. We have the doubling life and the half-life. Okay, the doubling life is whenever we have a quantity and it grows exponentially. So exponential growth looks something like this. It may start out a little slow, but then once it gets going, it just explodes. And exponential decay looks like this, a little bit flipped, okay? And so that means we're decaying at a really, really rapid rate. The equations that we use to describe growth and decay are doubling life and half-life. So the doubling life, I can't spell, is a period of time required for a quantity to double in amount, size, or value. So it could be applied to population growth, compound interest, so that could be like money, and other things that tend to grow over time. The way that we write this equation, the way that we model it, is nt is equal to n0 times 2 to the t divided by d. This is in the exponent. This is in the exponent. So n0, this is the initial quantity. Nt, this is the quantity after some time. D, this is the time it takes to double. And T, this is just time. The next equation, sorry, it's a half-life equation. So half-life this is the amount of time required for a quantity to decay to half of its initial quantity. So the equation we use to model this is very similar. It's nt is equal to n0 times 1/2 to the t divided by h. N0, this is the initial quantity. Nt is the quantity after some time. H, this is the time it takes to decay to half of the original amount. And we just said the original amount was n0. T, this is time. For both of these equations, T and H, so T and H down here and T and D, these must be in the same units. This is very, very, very important. They must be in the same units. They're measurements of time, so we need them to be in the same units. So as a practice, this problem is on radioactive decay. This is a problem we got on October 5th and October 6th, depending on what period you were in. So our first step, step 1, we need to circle key information. For this problem, let's just go through and read it together, and I'll circle the key information. Suppose that the half-life of kryptonite is 20 days. This means that it takes 20 days for half of the kryptonite sample to decay or transfer from matter to energy. Assume that you start with 50 grams of kryptonite. And in part A, we want to know how much do we expect after 20 days, 40 days, 60 days, and 80 days. For step 2, I need to identify my formula. And we have some pretty key words here. They're pretty descriptive. We know something about the half-life of kryptonite. That means I'm going to use the half-life equation. So NT is equal to N0 times 1/2 to the T divided by H. Step 3, identify variables. So I'm going to go through and write down what each variable is in this equation. I have NT, N0, T, and H. I'll work backwards. So H, this is the time it takes to reach its half-life, and we're given this in the problem. This is 20 days. RT, this is the time we're measuring our quantity for, and we have 4 in our problem, so we're going to have to find 4 different values. So we have 20 days, 40 days, 60 days, and 80 days. Our N0 is 50 grams. And for this problem, our NT, that is our question mark. That is what we are looking for. Okay, so for each of these, I'm going to write out an equation. I need to find NT for 50 times 1/2, and my T is 20 days. My H is 20. I will simplify before I put it into the calculator. 50 times 1/2, 20 over 20 is 1, and this is just 50 times 1/2, which is 25. My units here, this is 25 grams, because the original half-life was in 50 grams, the original quantity. So after 20 days, I go down to 25 grams. For the next one, it's 1/2. For 40 days, I would do 40 divided by 20. So 50 times 1/2, 40 divided by 20 is 2. So let me show you how to plug this into the calculator, in case you're having problems with that. So I'll zoom in. I have, let me zoom out so you can see what buttons I'm pushing. Okay, 50 times 1/2, and this is going to be to the power of 2. So I reach that power key by pushing the caret. And if I push enter, I get that that's 25 over 2, and I want to convert that to a decimal, so 25 divided by 2 is just 12.5 grams. Okay, so that's 2 examples, one for 20 days, one for 40 days. Those should be able to get you going for the 60 days and the 80 days. And I'll